All right, so first thing. Look, we talked about this in the first chapter. You can make a note of the postulate if you want. Not that big of a deal. It's more of know it exists, but we've already covered it. I mean, when we did the first chapter, we were talking about drawing points through a line. Even then, I would have talked about this. Okay, drawing a line through a point. And the fact that if I've got a line, there's only one way for me to draw another line that's parallel to it if I'm given a point. All right? It's it's a common sense thing. It's a postulate. Okay? If you need to see it kind of drawn out in order, the way it goes is I got a line, I have a point. There's only one possibility of another line I can draw through this point to make it parallel. I mean, if I draw it this way, it's not going to be parallel. If I draw it that way, it's not going to be parallel. Right? I could actually get it to the point. So the only option would be one like that. That's all the postulate does. It says you can draw one line through a point parallel to a given line. Okay? Again, it's not that big a deal. All right? It does come up. Probably going to be referenced in your work. That's why I give you as a named postulate. I highly doubt this will come up in a proof or anything like that. Okay, but probably on a test. I'll probably give you a question that might say, look, if I give you a point in a line, how many lines can you draw parallel to it? And you'd have to say one. Okay? So if you're not writing the entire thing out, it's not that big a deal. If you want to write it all out, guys, because I'm going to move faster. If you want to write it all out, go to the book, in the book, come directly in the book. Okay? All right. Now, on to the first stuff that's really going to be big. First thing is triangle angle sum theorem. Usually, prior to this class, most people have a general idea that if I have a triangle and I take these three angles and I add them together, most people before even this class have an idea of how many degrees I should get. All right? Does anyone know, like if I take those three angles and add them together, how many degrees they should be? 180. Okay? The whole triangle sum theorem is just that. It says sum of the interior angles of the triangle is 180 degrees. Okay. All right, which would lead you to problems like that. Now, it's built. What's happening, guys? Is it's kind of the reason this is going to be in this chapter is that the next chapter is going to focus solely on triangles. So it's kind of tying everything together. Get this out of the way now. All right, but you're also going to be doing problems that involve maybe some parallel lines along with this stuff. It's kind of taking things we do in this chapter, all right, in the next chapter and putting them together. It's like an in-between. All right. Now, your basic problems for this would be like these two right here. They give you two angles. They say, find the third. And they're just giving you the idea that, hey, if you know that they have to all add up to 180 degrees, you literally should just write out all the angles add up to 180 degrees. All right, so if I solve that out, that gives me how many degrees for that angle C? 50. What about this one over here? It's what? 45. Okay, is everyone okay with that one there, right there? Right, the box means it's how many degrees? 90. So 90 plus 45, subtract that from here. Yes?
Didn't know that you were right after
No. 10. I was just kind of doing that for the sake of writing an equation out through. All right, now, beyond these two. Okay? Moving to ones like this. Now, especially on the test, guys, I would definitely expect you guys to write out at least numbers that you're subtracting to get an X, Y, and Z up there. Okay, but what's happening is that's taking the thing you just talked about with the whole triangles, the angles adding up to 180 degrees, and it's adding it to old angle pairs that we have. With this problem, I could actually start with either an x or a y. We haven't gotten to the theorem that would allow us to do the y first. I would assume most people right now would find this value first. Right? If I asked you to find the value for x, how many degrees x is? Could you? Yeah, what would it be? It's what? 78. You said 78. What'd you do for it? So, what's 59 and 43? 102. And then just subtract that from 180. I agree with you. Alright, so here's the thing. If I know that's 78 degrees, how would I find the measure of y? What? Yeah, they're supplementary, so you just subtract it from 180. And the reason they're supplementary, right, that's a straight line, therefore those are a linear pair. Alright, so y plus 78 equals 180. Again, guys, on a test with these, I would expect you to have that work kind of written out. I need to see at least what you're subtracting or adding together. Because with problems like this, there's a lot of little tiny mistakes that could happen. You might copy a number down wrong or something like that, but if you're not showing me the work, I can't grade it. Right? I can't tell you what it was. Okay, so got that as 1 and 2. Now since I have this, can I find out what z is? Yeah. Alright? Because I got z plus how many degrees are these two together? 1. So z is what's 180 minus 151? Okay. Now, like I said, when we started this, I said I could have found y first if I wanted to, right? Because the answer for y was 102. The value I got over here was 102. There's a link between them, right? When I got this 102 for the x part, I was adding together these two angles. These two values for the angles I added together there are always going to be the same. That's going to actually give us the next theorem is going to be out there. Okay, so include the next thing is going to be dealing with exterior angles. All right. It didn't really look like it because y on that last problem, y was like encased in a triangle, but in relation to the triangle that was on the left, y was actually called an exterior angle of that triangle. All right. Exterior angles would be the ones formed by just extending the sides of the triangle. Right? The interior ones are easy. They're inside the triangle. On the outside, they're on the exterior. But again, the ones we're going to focus on are ones that we just are formed by taking the side of the triangle and just extending it out. Okay. Now, more importantly, ones that are drawn in the manner of the one right here are going to be pretty important as well. There's actually going to be two properties we get with it. There's a theorem that goes with it, and there's actually going to be a theorem for me taking all three of those angles and add them together. And that one really doesn't come up until we get to way later in the book when we start dealing with like other regular polygons and stuff, like polygons with more sides than 3 on. But if I just look at it now, if I took this angle, right, about like that, about like that, right? Kind of? Is that close? Yeah. All right, and then I drew this one onto it. It would be kind of drawn this way. And then this one would be that one right here. All right, so if I look at them, if I took all those and put them together, I basically have a complete circle. How many degrees are in a complete circle? 360, right? These angles, these exterior angles, if they're drawn in this manner where you just extend the sides out, they're always going to add up to 360 every single time. Even when we get to bigger polygons, like we get to ones that have like 20 sides, or 10 sides, or whatever, however many sides, it doesn't matter. These angles will always add up to 360 degrees. Okay? So that's one property good. All right? The other thing is going to deal with a shape or a diagram similar to the one that was just up there when I did the adding up the interior angles. Okay, and that's this one right here. This is actually, I don't know why it's covered up, but this is the exterior angle theorem. All right, so basically what it says is that if you've got a triangle, right, that's basically a triangle, and I extend one of the sides out, creating an exterior angle, I can always find the measure of that angle by adding together these two interior angles that are not right next to it, not adjacent to it. All right, that's why I said on that last problem, I had these two measures, and y was technically right here in the problem. It was enclosed in a triangle, but didn't change where it was at. I could have started by adding those together, getting that number. Okay, as opposed to adding them together, subtracting from 180 to get x. It didn't matter how it started, I got the same answer either way. Okay, that's just an alternate approach to the problem that was up there. Okay, so for this one to work, though, the way the theorem basically works is that if you have an exterior angle, if you want to get it quickly, you can just take the two interior angles that are not next to it and add them together. They have to be the two that aren't adjacent to it. All right, because if you knew the one that was adjacent to it, you would just subtract it from 180 to get that measure, because that would be a linear case. All right, so that's just an alternate thing. You can always work around this guy's theorem. There's probably going to be enough information for you to find this angle first, subtract from 180. Okay, so this is a theorem that will save you time, like most of them do anyway. You say that, like, if you know the theorems, they're kind of shortcuts. But if you forget about it, it's not that big a deal. I mean, you're always going to be able to find this measurement as long as you have those two ends. Okay, there's always ways around it. Yeah. Wait, what's the degree for that? Okay, so real all right, guys, it's been about time. So, go through answers here. First one, you should get x and y equals 60. You could have done it either way. You could have done like 180 minus 120, you got 60 right here. Add those up, subtract again from 180, realize it's 60. You could have found x first by doing 60 minus 120, it doesn't matter. Because these two add up to that angle on the outside. We didn't have to use this. Again, on 26, we get the measure for this angle here. What was the measure of y on 26? Which makes x also 45. Not 60, 60. Okay. Down here, all it asked was find the value of x. You didn't have to find x and plug it back in or anything like that. Okay. So for this one here, you got a different answer.
30.
30, right? Because they all together have to add up to 180 to get 3x plus 2x plus x is 6x equals 180. Then 28, again, you add them up, they equal 180.
55.
5. Again, this one, add them together, equal 180, you get 3. Is everything okay right now with this stuff?
Everything is great.
Sure. Are you sure? There you go. All right. Second part of this stuff. Okay, this is all going to be focused on equations of lines. All right, so this goes back to algebra stuff. Should be more of a review than the stuff we've done prior to this. It ties into this chapter because we start dealing with slopes, comparing lines. You compare them, you've either got intersecting lines, parallel lines, or perpendicular lines. Okay? And it's really all going to revolve around the slope. First thing, you guys remember what slope is? What? Right away. That's the slope intercept form. That's more rise over run. Okay, so rise over run is just talking about how much a line rises in relation to how much it goes, runs left to right. All right? In reality, what slope is, just like it says up there, it's a measure of how steep a line is. Obviously, the greater the number, all right, in relation to like us looking at integers, like the higher the number, the steeper it's going to be. The slope of 10 is obviously much steeper than the slope of like 2. Okay, even when you do it to negative, the slope of negative 10 is a lot steeper than a slope of negative 2.
What is it ever going to be called?
I might use that every now and then, just so you know the two are interchangeable. So if I ever do say gradient, because of the IB classes, I teach this how they say it. So I just interchange them, not think it's fine. All right. You don't need to write out every little thing. I've got a whole bunch of stuff up here just to remind you of little things with slope. Okay. Essentially, this part right here, the thing that I have here, it says the slope of the line is determined by the fraction vertical step over horizontal step. That is the rise over run portion. Right? That's your rise right there going up and down. The horizontal part is always the run. Rise, run, so on and so forth. Okay? And another thing to keep in mind with these, when you do slope, if you're trying to determine if it's positive or negative, just always remember you're looking at it from left to right. I mean, if the line is obviously going in an upwards motion from left to right, like if I look at this from left to right, if I just trace it, it's going up. So I know this one right here has a positive slope. All right, I don't know what it is, I just know it's a positive slope. Whereas this one, if I look at it left to right, has a falling motion, it's going down, so it's going to be a negative slope. Now, I say keep that in mind because if there's a line graphed out and you do the simple thing where you just pick a point and you count to the other point, like you count over this direction and count up. If it's going this way and you get a negative slope, hopefully you would stop yourself and go, there's no way that can be a negative slope. I miscounted, or I forgot, to change something. Something would key you off. Okay? Same thing here. If you got a positive slope for that one, I would hope you look at the line and go, there's no way that can have a positive slope because it's going down. All right? That's kind of how those work together. Now, what letter represented the slope for you guys? What was the letter? What was it? M, right? So M was in general the letter represented slope. Now, if I took all this rise over run and the counting stuff and put it together into an equation, you always had an equation that, again, between 2 points, so this is slope between 2 points, like if you want to write that out. slope between 2 points, was y2 minus y1 over x2 minus x1, which again is simply change in the y coordinates over change in the x, which is vertical step over horizontal step, right? And for you to get the x2s and the y2s and all that stuff, the 2 points, remember I'm technically referencing our 1 point with x1, y1, and the other point is x2, y2. The biggest thing is you just remember, subtract the y coordinates on top, subtract the x coordinates on the bottom. Biggest mistake people make, the x is on top and the y is on the bottom. Okay? The subtraction part, people usually mess up. Usually the things people mess up are the ordering of the two. Okay? Now, all this is brought up again because, right, this chapter is focused on parallel lines and to a point perpendicular line. If you remember, right back in algebra stuff, you took these things, you took slope, you compared slopes, you decided if lines were parallel or perpendicular based on their slope. Right? And every now and then you had, neither answer, like they just intersected, or they could have been the same line with the other options. Right? Alright, so with this part, with the slopes of the parallel and perpendicular line, do you remember at all how they work? Like if you took two slopes and compared them, how you decided if the lines were parallel or if they were perpendicular? You remember how the slopes had to match up at all? Yeah. If I said, here's two slopes, you tell me if they're parallel, what would you be looking for? Remember? Yeah?
They have different slopes.
What? Yeah, if they had the same slope, right? So if they had the same slope, that meant they were parallel. All right? And the opposite reciprocal is the one that was the perpendicular. All right? So, two lines are parallel if they have equal slopes, so exactly the same. So if one line has a slope of 2 over 5, another one's got a slope of 2 over 5, and they're parallel. As long as they don't have the same y-intercept, that is. Because then if they have the same y-intercept, they'd be the same line. And then, of course, you just said, right, the perpendicular ones are the opposite reciprocals, or negative reciprocals. The opposite and the negative just means switch the sign. So if it starts positive, it needs to be negative on the perpendicular one. Starts at a negative, the one perpendicular has to be positive. Okay? And remember, reciprocal just means flip the fraction. Like 2 over 5 and negative 5 over 2 would be perpendicular. All right. The second thing I've listed under there is just to remind you, like they're graphed out. And you're going to have somewhere, they're going to have a line graphed out, okay, to be able to tell specific points that'll be in the book that way, or the workbook, or wherever the heck the work is for that. The question is still whether or not they're parallel or perpendicular. Like, you might have a couple where you can look at them and just tell whether or not they're parallel or not. The perpendicular is generally a little harder because they can skew it a little bit, and it would still look like it makes a right angle where it really doesn't. But in both cases, make sure you are always checking the slopes of them. All right, to make absolutely sure that these things are parallel or perpendicular. If they're graphed out, I would never expect you to use the y2 minus y1 over x2 minus x1 formula, like the actual slope formula. I would more expect you guys to count, like from one point to another. Okay? Because it's easier. You're not subtracting anything, you just basically count. Okay? The biggest thing to remember, right? So parallel equal slopes. Like I said, you got one that's m equals 3, another one that's m equals 3. They're probably going to be parallel. All right? An opposite reciprocal, just if you needed to see it, would be like 3 over 5 and negative 5 over 3. Those would be perpendicular. Okay, just so you kind of in your head remember. And again, if it starts at a positive, the other one needs to be negative. All right, as long as the signs are different. That's what the whole negative or opposite means. Now, next one. I'm going to go past this guy. Yes, no? Okay. All right, so what I was saying with the whole counting thing. If I had those two there, again, I wouldn't expect you guys, like you would need to do this part down here. Like you would need to have the slopes. Because the question probably would be, look, here's two lines. You tell me whether or not they're parallel or if they're perpendicular. Something like that. And for you to verify it, like you can probably look at it and tell they're going to be parallel, but to actually verify it, and on the test, guys, I'm going to ask you to justify your answers. That means you need to find the slope and show me that you found the slope. All right? I wouldn't expect you to do this formula, like I said, if it's graphed out for you. I would simply expect you to go from this point to the next one that's hitting like the little crosshairs, right, on your XY axis. You have to go to the right one and up 3. Okay, so that means your run is a positive 1 because it's going to the right. The rise is a positive 3 because it's going up. That's where the 3 over 1 is coming from. And that's why you kind of need to remember the whole rise over run part. Graph out, guys. Don't waste your time on that. Just count. Okay, you're going to produce too much work for yourselves if you start trying to pick points on there. All right? Now, this part. Okay, so this is another big thing in this part. Is writing the equation of the line. Okay? And this will carry on over until you get done with math in high school. You're going to be writing equations of line in almost every class. Okay? So it's a pretty big thing you have to kind of get in your head, even if it's stored to the side for next year when you get to Algebra 2 kind of thing. You're still going to be asked to do this in Algebra 2. The one form you guys already told me was that one. I heard that. Because if I bring up slope, that's just what pops out of people's mouths, right? So this is called slope-intercept form. Right? And it's slope-intercept form because the m is the slope, right? That's your slope. Whatever the slope of the line is, from either doing that formula or just counting. Okay? And that B represent your, what's the B represent right there? The what? And that one, we just said where the line starts, that could be anything. The y-intercept, that's right. So this is your y-intercept. And remember, guys, y-intercept, that means where it crosses the y-axis. All right? So in terms of graphing these things out, like this form is good for graphing. All right? I mean, it's a pretty good form for graphing, especially when you just start graphing. If I did one, and I said like y equals negative 2x minus 1. All right? I would know, I could look at that equation and go, that's my slope. All right? I know my slope equals negative 2. Right? Technically, negative 2 over 1 if you want to think in terms of rise over run. And this whole thing right here would be my y-intercept. So if I were to graph this, and this is the reason this form gets used a lot in like algebra, it's because you can graph this pretty easily, right? And when you graph this, you said it's where it starts. So it starts at negative 1, and then you just count the slope. So if I was counting a slope of negative 2, and I started at this point, how would I count to my next point? So go down 2, and to the right one. Or I could go up 2, and to the left one. As long as there's one negative motion there, right? To the left is negative and down is negative. And then you just kind of draw the line as best you can. Okay? So that's one form. Another form. Can I make this disappear? Another form is this one. Okay? Point slope form is the form I will use the most to write the equation of the line. In this point slope form, the m still means the same thing. M still means the slope. X1, Y1 is some point on the line. Okay? So it doesn't matter what point it is, it's just some point. These are going to be the main two. Alright? If you remember how to do it by doing slope-intercept form, then where you plug numbers in, you get B and all that stuff in algebra, do it that way. On the examples I have, unless I flat out tell you what the y-intercept is, I'm going to use this one. It's just easier. It kind of takes all the work and puts it in one step for you. All right, these are the two main ones. Okay, so just on this one, M always means slope. X1, Y1 is a point somewhere in the line. Doesn't matter where it's at. It could be a y-intercept. It could be a just random point, like 2, 2, whatever. The other form, as it says, right, 3 different forms, is standard form. You're probably not going to see this as much. This is another form that works good for graphing because you can get the x-intercept quickly and the y-intercept quickly. And then just plot those two and connect those points. But I doubt in Algebra 1 they really stress that form in terms of writing things in that form to graphing quickly. All right, most of it focuses on this in Algebra 1. So, and we're going to focus on the first two anyway. Okay, you're probably not going to see standard form that much. All right, now, let's do some examples. Hopefully that's what you have. All right, so write the equation line. Oh, here we go. I'll give you these steps, then we'll do the example. So we're going to be ready. Okay, so your whole process of writing the equation of line. Very first thing you want to do, get the slope. If you don't have the slope of the line, you're not going to write the equation of the line.
Do we write all the
You could probably shorthand it. I've got more up there probably than I would write. Like, if I've got step 1, find the slope, I know what to do first. And you've got the stuff beforehand to lead you on that path. For you guys, they're either going to tell you what the slope is. Like they'll say, okay, write the equation of a line with a slope of 5. Which that's pretty much done for you if it's that case. All right? Or they're going to say, like, write the equation of a line through points 1, 5, and -3, 6, or something like that. If they give you that, then you have to go up there and do the whole slope formula to find it. The whole essence is, guys, first step, find the slope.
Gotcha.
Yeah. We're out. That's all. All right, second thing, and this is 2a and 2b. Because here's the thing, if they give you the y-intercept, you just do y equals mx plus b. You're going to plug 2 numbers in, you're done. All right? So if they give you the b part, you just take it, you plug it into slope-intercept form, and you're done with it. If they don't give you the y-intercept, all right? If they do not give you the y-intercept, and they give you another point like 2, 8, -4, 6, whatever. You take that point, plug it into your point slope form. All right, this is how I'll do it. Like I said, if you are comfortable doing it with the way they probably did in Algebra 1, which is plugging the numbers in and getting B, then do it that way. But any kind of example or any kind of homework I go over, if I need to do one, I'm going to do it in this form, with point slope. All right, and then the last thing is simply rewrite the equation into whatever form they ask. Most of the time, I'm going to ask you to have it in slope-intercept form, or the book will have me ask you to do it in slope-intercept form. But really, after the second step, you're done. You have the equation of a line, it's just not in a nice, neat form. Okay, so find the slope. They give you y-intercept, just stick with y equals mx plus b. If they give you another point that's not the y-intercept, use point slope form, and then rewrite it. Right? So, let's do probably like maybe 2 examples. 2 or 3, depending on how easy it is. Okay. Let me go past this guy. All right. I might just skip over the graphic. Okay, so with this one here, all right, so write the equation of the line, slope 2, y-intercept of 3. If I go through the little steps I had on the last one, that first step is find the slope. Do they tell you the slope? Do they? Yeah. So there's really no finding. It's just, there it is. There isn't much else to it. All right, second step. They give me the y-intercept?
Yep.
This is the one I said, these are the easiest because they give you M, they give you B. All you have to do to write the equation of a line is take that form and replace M and B with those numbers. You're done. Okay? These are the easiest ones, they're the quickest ones. Shouldn't be that big of an issue with these. Alright? If I went through graphing it, you don't need to worry about drawing the graph out, do something like that. There's my y-intercept. I'll go up 2 to the right 1 to the positive 2, and then just kind of, okay? So the easiest type of problem for equation of the line. They tell you everything. You just got to remember the form and plug in numbers. All right? Can I go past this? No, we're going to. Next one. Now I'm starting to extend it a little bit because now, using the words like parallel, that one's perpendicular, so on. I'm not giving you the y-intercept, it's a little bit more involved. But it doesn't change the steps. Like my first step is still find the slope. I need to know what the slope is. Okay? What's the slope of the line that I'm going to be writing the equation of? 3. How do you know it's 3? Because it's parallel in this equation, that's the slope right there. Like, so for this equation, the slope is 3. Parallel has to be the same. Do I give you the y-intercept?
No.
No. If I don't give you the y-intercept, guys, what I'm saying is use this form. Because all you have to do, take those two numbers for x1 and y1, take your slope, and plug them in. So it'll look like y minus 4 equals 3 x minus 2.
Why is it so y-intercept negative 2?
The y-intercept is negative. It's negative 2 for this line, but it might not be for this one. Now here's the thing. It doesn't say write it in slope-intercept form. Like remember the third step, I said write it in the appropriate form. Nothing's really specified up here. It looks nice as if you write it in slope-intercept form, which if I do this in slope-intercept form, would look like this. Which ends up being the same line. Numbers stunk in this case. Oh well. But if you would have stopped right here, chances are I probably wouldn't take off because I did not specify where it was. Like if I don't say which form to put it in, and you stopped right here, I mean that's the equation of a line. You've got it's just in a ugly looking form, but it's still the equation of a line. So if it doesn't specify, guys, if you get to this point, you just stop. I'm probably not going to take off. Okay? All right. So one other thing real quick. Just make sure you're pulling the slopes correctly. All right? They don't take that long to do anyway. If I give you this equation here, it says I want the equation line perpendicular to this one. First step again is find the slope. Slope I'm going to use is what? -4. So this original slope up here is 1/4. Perpendicular means opposite, reciprocal. Opposite, reciprocal would be that. Okay? Make sure you take note of that. That's not the y-intercept. So I'm using that form. It could happen, but it's not like the next step. Now again, it doesn't say which form it's in, guys, so you can stop there. That's fine. Okay, and I wouldn't have an issue with it. Just because it does not specify. If it says right in slope-intercept form, then you would go through the work and solve it out. Like if I said write this in slope-intercept form, why did you this original slope is 1/4. The opposite reciprocal, that would be 4/1 negative. Okay, so if I said slope intercept form, it would be that. Read the answer, be fine. Okay? All right.